In this video, we're going to take a look at the solutions to these three systems of equations solved by graphing. So here's A here. We're asked to graph y equals 2x minus 4 and y equals negative 4/3 x plus 6. So for the first one, the 2x minus 4, the slope m value would be 2. And remember, 2 is the same as 2 over 1. So 2 is the rise, 1 is the run. And the y-intercept of this line would be negative 4. So on the graph down here, we'd put a dot at negative 4. And if the rise is 2 over 1, we go up 2 and to the right 1, and there's another point in the graph. Up 2 to the right 1, and there's another point in the graph. Up 2 to the right 1, and do it a few times so we can graph this fairly accurately. So this is what that line would look like. Move that over just a little bit. That's pretty close. So that is y equals 2x minus 4. So this one here, the slope, the second one, the slope would be negative 4/3. And the y-intercept would be 6. So for this one, so 6 is the y-intercept right there. We start at 6. We go down 1, 2, 3, 4, and over 3. So that's actually a point where that's actually the point of intersection right there. 1, 2, 3, 4 over 1, 2, 3. Be another point right there. And we can draw the line between them. And so that is the y equals negative 4/3 x plus 6. And so we see that this point right here, which is the point 3, 2, would be the point of intersection. The second one is this y equals 2x minus 10, minus 2x plus 10, sorry, and y equals negative 5x plus 7. So for the first line, if we write the slope in the y-intercept, then m is equal to negative 2x, that's negative 2, sorry. Negative 2, and the y-intercept of this line would be 10. So we start here. Now negative 2 is the same as negative 2 over 1, so down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Do that a few points. Of course, if we went over 1 and up 2, that would be another point there too, and we could graph this line. So that is the y equals negative 2x plus 10 line. So the second one here, the slope would be the negative 5, and the y-intercept is at 7. So we put a dot at 7 here to start, right there. And now negative 5 is the same as negative 5 over 1. So if we go down 1, 2, 3, 4, 5, and over 1, there's another point. 1, 2, 3, 4, 5 over 1, there's another point. If we go in the opposite direction, remember, you can, instead of having the negative for the rise, you can have it for the run. So we could put 5 over negative 1. So 1, 2, 3, 4, 5 and over 1. Well, actually, there's the point of intersection right there. Maybe I'll make a dot and then move it over here. And we'll graph this line here. And we're actually just up off the top of the graph. But you see, this would be up 1, so that's 12 high, and it went over 1 this way. So that would be the point negative 1, comma 12. So that's the point of intersection for B. The last one here, and I'm going to use the intercept method to graph at least one of these because the first two were both in y equals mx plus b form. So what I'm going to do first is I'm going to rearrange this. So I'm going to subtract 12 from both sides, or bring the 12 over. And so that equation, see, the negative 12 would be what would be on the right side. Now, so let's say I want to find the y-intercept first. So I'm going to put 0 in place of x. And we would solve this for y. So basically that's gone because 3 times 0 is 0. And so we would divide out the 4 like this. And so y would equal negative 3. So the y-intercept is at negative 3 right here. Put it not there. And so now let's find the x-intercept instead. So we would put a 0 in place of the y here. Negative 12. And so basically that's gone. We're solving 3x equals negative 12. So divide out the 3. And the x-intercept is here at negative 4, which would be right there. So we could draw a line between these. So let's see. So it would look something like that. So that's this line. We'll put that there somewhere. Now, we could have also solved for y and put it in y equals mx plus b form. So let's do that too. So I would want to get isolate the 4y terms. So I would bring the 3x and the 12 over, or subtract 3x and subtract 12 from both sides. So if I did that, and also subtract the 12. So those are gone. So we would have 4y equals negative 3x minus 12. So let's write that down here. And then to isolate for y to get rid of that 4, we would divide out the 4 like that. So this is the slope y-intercept form, if you prefer that. Of course, if you're asked to graph them, you really can use either method. So the slope would be negative 3/4, and the y-intercept would be negative 3, which is we already found above. Okay, it's negative 3. So slope of negative 3/4. So if I go down 1, 2, 3, and over 1, 2, 3, 4, see there would be a point right there. And of course, that negative 3/4. Remember, you can write that as 3 over negative 4 if you want. Put the negative in bottom. So for example, from here, 1, 2, 3, positive 3, and then 1, 2, 3, 4 gets you to that point. So that's that line. Now for the second one, I would rearrange here and want to take this 18 over, or subtract 18 from both sides, and of course that 18 would become negative. So that's what that one would look like, it's rearranged. Now let's say we want to find intercepts again. So let's say we substitute 0 in place of x. So we would go 5 times 0 plus 6y equals 18, or negative 18. And so that's 0, that's gone. So we divide out the 6 here. So the y-intercept is negative 3. And I meant to make this a different color. So the y-intercept is negative 3. Well, look, we found the point of intersection already. Look at right there. It's negative, same point as that. So let's say we really haven't really finished graphing the line. So let's say we finally find the x-intercept instead. So we'll put 0 in place of y. So 5x plus 6 times 0 equals negative 18. So that's gone. So now we would divide out the 5. And so now this is the problem with the graphical method. 18 doesn't divide, or negative 18 doesn't divide evenly by 5, so automatically we're getting into a little bit of difficulty graphing it. So 18 divided by 5, just to show what that looks like. Bring our graphing calculator over here. So negative 18 divided by 5 is negative 3.6. So x-intercept is negative 3.6. So that's around here. Of course, if you want to put it in y equals mx plus b form, that would be more accurate. And just let's do that. So if we were to isolate for y here, so all I really would need to do is rearrange and take this 5x over. So I would have 6y equals negative 5x minus 18. Dividing out the 6. This is the slope y-intercept form. So it would be negative 5, 6x, and negative 18 divided by 6 is negative 3, and there's the point of intersection again. So negative 5, 6, and of course, if you want, remember, you can also write that as 5 over negative 6. So if you're starting at the this point here, we could go up 5, so 1, 2, 3, 4, 5, and then over 1, 2, 3, 4, 5, 6. So that would be a point right there. Okay, looks like our line's pretty good. So the point of intersection is this point here, which would be the point 0, comma, negative 3, and however you graph them, that is the point of intersection. And that's the end of the video.